Hello everyone, my name is Jasper. I'm a student at the Delft University of Technology, and I did my internship here at TNO, where along with my colleagues Daisuke Kaneko, Stuldreher, Hilmar, Zech, and Brouwer, we wrote an article on an accessible tool to measure implicit approach-avoidance tendencies towards food outside of the lab. The main outcome of this research was that the mobile AAT tool developed by Hilmar and the developed open source processing pipeline by us may be used to implicitly measure both valence and arousal towards food. And this is quite an interesting finding, but before we dive further into this, I'd like to introduce the approach avoidance task itself. As the name implies, it's an implicit measure of our approach avoidance tendencies, and it works based on the principle that we have an approach motivation towards positive stimuli and an avoidance motivation away from negative stimuli. And traditionally, this is modulated by our reaction time towards the presentation of these stimuli. In food literature, the AAT has been used in research on healthy eating, food craving, and eating disorders, and we believe that this can be extended towards research on food experience itself. In particular, we use a mobile variant of the AAT developed by Hilmar, which can be deployed remotely, which is one of its nice advantages. And the MAAT works as follows, where participants, upon the presentation of a stimuli, either pull the phone towards them or they push the phone further away from them. And what exactly to do depends on the instruction that they're given. For instance, if you look at condition 1 here, participants first pull image set A, so this could be, for example, vegetables, and they push image set B, which could be, for example, fruits. And then they do the opposite after a certain number of trials, such that they both pull and push each image set once. And this is typically counterbalanced across the total number of participants. Our contributions to this was that we improved upon the processing pipeline initially developed by Hilmar. For instance, we added corrections for the rotations of the phone during a movement, and we added more robust filtering, and we added a new metric to complement the existing ones to measure our approach avoidance tendencies. And this metric is the reaction distance, so it's physically how far or how close participants move their phone. The code is open source and available in the following GitHub link. And we also developed this easy-to-use graphical user interface such that those with minimal programming experience can also use the tool. Here we have an example of one of the windows of the graphical user interface, wherein participants can customize their processing parameters, for example, set their filtering thresholds. And here's another window where a summary of the current processing is given, and some results highlighted in blue are also summarized. So in order to evaluate how well the pipeline itself works, and in order to also evaluate the sensitivity of the mobile AAT to food-evoked emotion, we decided to run a pilot study with the authors of this manuscript using extreme stimuli, namely unmolded and molded food images from CrockyFid. And here we have an example of some of the unmolded images used and some of the molded images used. The results you see here. So here we have the pull results, and here we have the push results. What we can see from the acceleration graphs, which is the top two, is that the expected biases are indeed seen, namely that in this case we have a faster reaction time towards unmolded food, since the orange curve precedes the blue one. And we also have a stronger force when reacting to or pulling these unmolded images. And likewise, we have a stronger force and react faster to pushing molded images, which makes sense. However, what is counterintuitive is that regardless of pushing or pulling, we move the molded images closer to us or further away from us. So this makes us suspect that the reaction distance may be more indicative of participants' arousal. Results of this pipeline show that the pipeline can effectively process the mobile AAT data. The expected biases, at least in extreme stimuli, are seen, and the reaction distance may be more indicative of arousal, which complements the reaction time metric nicely because the reaction time is more indicative of or reflective of our valence. Our recommendations for future research is that the reaction distance metric should be normalized because at the moment it doesn't account for differences in arm lengths. Estimates can be improved by using more robust filtering methods or sensor fusion, so for instance, a Kalman filter. And the mobile AAT could be applied to less extreme stimuli, which is actually something that we're currently looking at. Namely, we're looking at the differences or biases between Dutch and Asian images. Thank you everyone for listening.